Hello guys, welcome. Today we have good news. I have done some comparisons of all those languages that I was talking last time. I was able to make them compile, run them, benchmark compilation, benchmark runtime, and the results are right here. Okay, let me move it. Okay. By the way, the easy to debug one, this is what we are gonna try to do in this video. See if they are easy to debug. Last time I was trying to make SIG compile, right? But I was not able to, right? If you remember what I did in the last video. Now I have the implementations for all the languages and all that. And okay, so let's do a quick review of this chart. So these are numbers collected by me in my computer with the help of LLMs. So this code was written between LLMs and me. We both wrote the code because LLMs are not perfect and I have to be fixing the mistakes. So, okay. Some languages were easier to do than others. Okay. So start. First we have the standard compile and runtime. Here optimization's on. For some languages I couldn't figure out or they didn't have optimizations. The tooling size and IntelliJ support. Okay. And here we have a separation of languages that need semicolon at the end of every line, which are dlang and SIG. Okay. Okay, so which one compiles the fastest, which is the first column right here? Compilation time. And the winner, the undisputable winner by a long shot in that category is B. So Blang compiles quite fast. Followed by, I would say Julia. Why? Because Julia is an interpreted language, so both compilation and runtime was 437, right? And in any way, the next one that comes after this one is dlang, which is 437, actually the same, but this Julia time includes the execution time. Okay, so the compilation time has to be less than this. It has to be like around, it's an interpreter. I don't really, not an expert in that, but let's say that the equivalent compilation time of this would have to be probably 250, right? Which we don't have. I don't have any way to know that, but maybe 250. So in terms of compilation, why is compilation time important? I mean, it can be really important because if you're developing like this one, and you want to change just one digit, for example 10 million won, to see that reflected, you only have to wait 200 milliseconds here, which is great. And of course, remember this number is for this simple binary search implementation. Imagine now that if you have thousands of lines of code and tens of and hundreds of files, this number will grow a lot. As you can see here, we have a red flag. 14 seconds Kotlin native. Can you believe that? So even if you just change one letter or one number, you have to wait 14 seconds to recompile. That's just not great. That's the reason I would say Kotlin is the first one that I would discard, unless I already have Kotlin JVM code that I can easily port to Kotlin native, and then I can easily benefit from this, but that's not a regular recommendation. Maybe for really small amount of people, Kotlin native may be a good idea. And also the tooling, which is a lot less important. This is a lot less important number, but is greater than 1 gigabyte because it has to install its own GCC, its own LDDB, its own GDB, its own Clang, its own LLVM, its own JVM, its own JDK, whatever. I mean, it's just crazy. I mean, but it has good IntelliJ support. Now in runtime here, it has this, but it doesn't matter because it took too long to compile that this doesn't matter, and actually it gets beaten by when we enable optimizations, it gets beaten by B, by D, and has the same like nim as nim. Okay, so that's compile time. The winner in compile time, Blang, followed by Julia, followed by D, followed by Odin, followed by Nim, and there will be like the fast. There ends the fast. Now the medium ones would be Sig. It takes 2 good seconds to compile a small program, and also Crystal, again 2 seconds. It's not a lot. It's not a deal breaker as 14 seconds, but still keep in mind how that number will grow as your code size grows, right? So that's compilation speed. B is the winner, and then D is great. Okay, now runtime. Runtime, the winner is Kotlin native here, but of course it's not worth it because of this, so we basically ignore that. And then it comes Nim, actually. As you can see, Nim it only had 125 milliseconds. This is none with optimizations, not really off, but the standard, whatever the compiler does by default. Okay, so Nim goes first. Not actually, D goes first, as you can see right here. D goes first with 118. Then it comes Nim, 125. Then Zig, 153. Then B, 213. Then Odin. But again, here, this Julia one may be the same as Odin, because 200 for compilation, 200 for run, maybe, right? Maybe. But maybe that's comparing apples to oranges, right? But okay. Julia also has a big tooling. However, Julia it's easy to get up and run in Julia, should I say. It was easier, even though it has large tooling. Okay. So what can I say from this? Which ones are the fast and which ones are not that fast? Well, the only one that is not very fast in this regard is Crystal. So Crystal is not that fast. We have to say that. Crystal would be the slower one of this. And also is this, without counting Kotlin, is the slowest both in compilation and execution. So probably, unless you have a use for it, I mean, it's not very slow, but this is the slowest of the fastest, right? But yeah, it has quite a big difference. Even with Odin, which is the second slowest, it has a big difference, right? It's like probably 70% slower than Odin. And that's quite a bit. And okay, so now here we will see optimizations on. Optimizations on, I mean, B wins in runtime, but it took 6 full seconds to optimize this, so it's not very fast in compilation. But this is okay because you can just do this when you are going to deploy, right? Otherwise, you have the fastest compilation ever, right? 200 milliseconds. Nim, this is better. It's better. It's just 2 seconds, and it went down to 73, which is great. But the winner here is D. Why? Because it only took 600 milliseconds and went down to 47 milliseconds execution. So I would say that the smartest optimizing compiler is the lang. Okay, so this is the smartest optimizing compiler. Now I would not like to write a semicolon at the end of the line, but okay. Now tooling size in megabytes. If you want the smallest tooling size, if that's an indication how light is your backpack, then B has the smallest, followed with 90 megabytes, followed by NIM with 96. Then we have D with 247. Then we have a tie between Crystal and SIG with 311. Actually, no, 229 Odin. Then D, then SIG. Then Julia with a bit larger, which is 624. But that's not bad. I mean, if you enjoy Julia, this tooling size is not very important. And Kotlin, the heaviest of them all, more than a gigabyte. I don't even know how big this is, right? Maybe a bit more even. IntelliJ support, Beelang has good IntelliJ support, Nim has good. Julia, like not very good. Crystal, bad or non-existent. Kotlin, bad, and Odin, bad or non-existent. Kotlin native has good support, but maybe because IntelliJ is made by the Kotlin makers, but they focus main Kotlin JVM. I don't know how much they focus on Kotlin native, but okay. D has good support and SIG has bad support. Okay, so here you can probably look at this and maybe decide by yourself. What you can do, I guess, unless you have a really, really good use for, you could discard Crystal and Kotlin. So let me move this, guys. Probably just to put them below. Okay. So Crystal and Kotlin, I would not recommend unless you have a reason, right, for them. Maybe you like something about Crystal or something. But in terms of performance, these are the losers. Every other language is fine in terms of performance. But these guys, Crystal and Kotlin native, are the losers. Then if you want fast compilation, you can go up to Nim. So B, Nim, Julia, Odin, and D. Probably SIG if you want to wait a second and have more. But yeah, it's not that bad. However, it may grow over time. Okay, so, but how easy are they to debug? That's an important question, very important question. Is you may notice that sometimes I'm a bit impatient and I don't know how to solve problems, and sometimes the language does not give you good output on what is going on, so it doesn't help you very much. Like if you remember last time in the SIG implementation, I was trying to figure out why it didn't work, but compiler told me what happened. The crash where it comes next, but doesn't tell me where it comes from my actual code, which I care. That is what I care actually. So let's try to break the programs in the same way and try to see how they behave. Okay, I don't know which one I have opened right here. Oh, D is D. So let's say, how can I open this? I would like to do if I want to do a segmentation fault. If I put +1 here, that may create a segmentation fault because it will point to N, and that will be like outside the memory. Okay, so here it seems to have problems and says possibly undefined symbol, it says, but I don't know what this means. Okay, I will run this. Oh, we have an error and it says index is out of bounds of array length, whatever. Okay, that's great. And it says is an app.d at line 8. At line 8. Amazing. As you can see right here. That's all I ask. That's all I ask. You just tell me the line and I will figure that out. Okay, and you say, okay, of course, because this is accessing 1 plus 1, which shouldn't be doing it. And here you can say that I improved that and it got fixed. Okay, so I mean that's good. I mean that's how I would figure out this, I guess. But I'm not sure. Maybe every language can do this, and if that's the case, then I may have to search for something else to benchmark them. So let's go with the next one, but let's at least save for now. Save the D result was a good result. Good. Okay. Great. Now let's go with something else. Sig, for example. Sig. Okay, let's go with Sig. So we close. The Sig one is this untitled, I guess, right? Yes. So this is where I was last time. But okay. Let me run it first. Maybe this is the code of this is not very clean. This takes a lot longer to run, as you can see. And here we probably have a problem here. It's not working. Why it's not working? Well, we'll have to investigate that. Oh yeah, it's working. The number is 6, it says right here. So that's what it should say. Okay, let's clean this a bit. Let's delete what's not being used, just to keep it cleaner. Okay, so here I'll do the same. Pointer plus 1. All right, that will be the equivalent. So let's run this. And we have something. Let's see. It says index out of bounds, index whatever. Okay, but where? See, line 20. Oh, great. So it says that. It's great. Yeah, it's good. Good. It's easy to debug. I mean, kind of, right? So I would say Sig. Set Sig to good. Okay, maybe everyone will, as I said, I don't know if everyone will score good, but we'll see. However, the last time happened something rather strange with this. Probably I should test something about that. Let me see. So actually to be able to do this, you have to have a heap allocator and general purpose allocator, whatever, in order to be able to allocate this size of array, which I had to like read for 15 minutes the internet to figure that out. What I want to do is try to instead of calling std debug print, I want to just call ol, or it's here it just says print. Can I just change this for ol? Will that work? Okay, first let's just do print. Okay, let's fix the bug. Let's run it again. It takes a while to compile, and the number is 6. Okay, so it works with print. Now can I just reduce this to ol? If it works, then I will forgive the previous errors of Sig. Undeclared. Oh, sorry. This is ol. Output line. I guess it will work. Why not? Number 6. Okay. So I forgive Sig. But still, there is a thing that I don't like a lot about Sig. That is that it doesn't have good support here in IntelliJ. But maybe some people don't use IntelliJ anyways, right? So, but previously I was you can watch the previous video to see how frustrated I was with SIG. Okay, so let's continue with the next one. Okay, let's go with nim. So here we have nim. Very concise code, actually. Okay, so nim. Let's make it crash. First, let's run it and see if it works. And says target found at index 6. So it compiles faster, as you can easily notice. And here, what we're gonna do is we're gonna add one here. Again, same bug as always. Let's try to reformat the code. Can do that. It says already properly formatted. I don't know if that's already properly formatted, but okay. So let's see if it crashes and it says something. It says unhandled exception index dot fatal. It says nim 45. Nim 45 and then 37. Oh, okay. Here it is. Okay, not bad. And again, fix them. Okay, it works. I mean, it's not that. I mean, I think everyone will get a good grade here, but I'm not sure. Maybe not. So good again, nim. Now let's go with blang, right? For blang, I guess it's this type plus right here. So blang, let's do index plus 1. Let's first run it to see if it says target found in index 6. So it compiles a lot faster. Plus 1, run again. Oh, didn't crash. Okay. Let's try to do that again. Didn't crash. Maybe that's not that good. We want it to crash or not. Well, I don't know. But oh, I'm doing it wrong. I'm doing it wrong. What am I doing here? It doesn't have to be index. What's index? I mean, I guess it's something from the thing. Okay. Okay, I'll do PTR instead. Right? Will that work? I mean, I don't know. I don't remember why this is using the word index. I guess there's something from B. No idea. So let's see. Okay. Okay, same thing, but it doesn't crash. I'm sorry. I'm doing something wrong here. I'm in binary search.sig. What am I doing? Okay, forgive me. Okay, but still I don't know. I mean, in SIG, I guess it's index what you use, right? Well, I don't know. But we won't get into those details. Okay, so this is binary search that this is the one from B. Sorry. Plus 1. Let's see if it crashes now. It crashes. It says index out of range, whatever, and says, oh, not very easy to debug as array sets main, backtrace at B panic, backtrace. Not very easy. It doesn't tell me where. Or am I not looking at it very well? As far as I know, it's not telling me where the error is. Well, it says array set, but I only have that, but that's not enough. It should tell me where. Okay, can I debug B? Well, I want to find where the problem is. Okay, let's see if I can do that. Debug blang. I don't know how to do that. I don't remember. Probably I knew. Debugging C backend binaries default. G produce less optimized code with more debugging information in it. Okay, so we'll do G. I guess. G. We compile with that. Well, let's see. I'm not an expert in this, but okay, we will try to go into, oh, that's because I have this right here. I have to delete actually this from here. This is not working code. I can delete this C code because I was trying to do all of them from here. So that's why I got confused. Okay. Yeah. Okay. So now that I'm here, I will do B minus G dot, and then gonna go run typeless, and with that, do we have something different? And we still don't, I guess. No, we don't. 11, it says line 11. Okay, yeah, it's here, line 11. Binary search.b line 11. Right. In main line 11. So not bad. Just have to add an extra G, and that's it. Not bad at all. No, not bad. However, it's not the best, but I think it's still good. So still good. Okay, let's go with Julia, right? Julia. Julia. So here you can see Julia. And we're gonna do the same right here. And actually in Julia, it would be harder to do this, you know, because it doesn't allow you to do that, right? But we will force it, which I don't know if it's possible, but I would say numbers at n. So by the way, this is a plus for Julia because it will make it harder for you to even make the mistake. We'll do whatever, 12. I don't care. I don't know if it will compile and run, but I'll try. It says target found on index 6. Okay, so it doesn't crash apparently. Numbers at n. Maybe Julia has one addressing? I don't know that. Load error. Okay, so I think Julia starts indexes from 1. Okay, yes, I think so. Bound error. Attempt to access element at index this vectors int whatever base line 21. Okay, it passed the test. 21. So that's good. Oding. Let's see Oding. I don't even know if one of them I don't have it for IntelliJ. I think Odin is the one that I don't have. So I'll go with Crystal instead. So Crystal. Let's run to see if it runs. Can't find fight prelude. Okay. I guess I have to run it from the command line. I don't remember really. Let's see. Crystal. Well, not sure. Do I have Crystal installed? Yes, apparently I do. I guess if I say Crystal, then learn crystal.cr, it will compile, right? And run. Okay, it says target found at index 6. Okay, so now we will change this. I mean, this doesn't have the best IDE support, as you can see. Maybe can do something else to configure it better, but it's not that easy, at least. Okay, again, this is easy to do this. Okay, now we're gonna do and say numbers at n equals 12. The same I did with Julia. Oh, sorry, I forgot. I have to do it manually. Okay, and it says showing last frame, error, whatever, learn crystal, undefined local variable, method number. Oh, sorry, that's a mistake. It's numbers. Sorry. And okay, we have check index out of bounds exception, mutable main.cr. Okay, let me see if I am getting where the thing is. Unhandled exception index out of bounds, indexable, check index, mutable CR. That's not learn crystal 22 and 31. 22, okay. 21 is actually, but okay, I'll give it. I mean, it says line 20 here. It says line 22, but actually the error is in line 21. I mean, but yeah. Okay. It's okay, I guess. I'd say it's good. Yeah, so it's good. I mean, it's a bit hard to know, you know. I mean, this was not Odin, it was Crystal actually. But actually, I mean, if you want, you can use any of this. I mean, Odin is not that slow. Crystal is a bit slower, as you can see right here. And Odin, I don't know. Odin, where was Odin? I don't remember where Odin was. Let me see if I can find it. Odin, where are you, Mr. Odin? Program languages. Okay, this one is the Odin. Yeah, binary search.odin. This is the guy. Okay, let me open a terminal here because it doesn't work until J. Let's see if I can find the Odin thing. Oh, here's the compilation, even the timing for it. And you know, it's a lot less but you have already compiled it. It takes less. So Odin takes 670 when you have already compiled, but sometimes it takes more, as you can see right here. But okay, around that. What we're gonna do is we're gonna run it to see if it outputs 6. So binary search, it says index 11 in array 6. Okay, that's great. Now we're gonna make it crash. For that, we'll do a micro binary search at outing right here, and we will say, let me make this a bit larger so you can better visualize what I'm doing here. I plus 1. We save it and we will compile it again. I'll even time it if you want. So probably takes a bit longer than this, right? So probably we should increase the Odin time, but sometimes not. I mean, probably it's a bit larger. Probably we'll put like 970 would probably be better. Yeah, right. Okay, so then we're gonna run it and see if it crashes. And it says index it's out of range, instruction core dumped. And it says Odin 1016. Let's see if it's true. 1016. Great. Amazing. It works fine. We fix it. Again, it took 700. I mean, it takes between 900 and 700, so we'll put 800 as an average, right? Okay. And now let's time this as well. 231. And what was my previous benchmark number? 231. Exactly the same, as you can see. Okay, so I guess all of them work well. I mean, yeah. Good. And Kotlin native. I don't remember how I did Kotlin native. Let's see if I can find it. Oh, Kotlin native right here. Bin binary search. Okay. So I will show you that it. Let's see. Let's try the time. Kotlin. Let's see if Kotlin. Okay, I'm gonna benchmark it. Okay, you see that I'm not lying right here. I'm saying it takes 14 seconds because I tried it previously and it took 14 seconds to compile. It's a long time, too long. Imagine waiting all this time just to compile a tiny program. 16 seconds even, right? Okay, it's very bad. Okay, let's open this in a text editor. Okay, let's first open a new terminal. And here we're gonna do micro binary search. And let's make it crash as well. +1. Save, go back. And then we have to compile all this thing again. Just to make it crash. And then just to do that tiny change, I have to wait 16 more seconds or whatever it takes. It's a lot. 14 seconds. Okay. Now I'm gonna run it. I'm gonna say what's the thing? Program, I guess. And it has some sort of a mistake. Array index out of bounds exception. Too wide for my taste, but okay. But it says okay, program c. I guess this is 23. Init plus 23. Is this the line? At 4? At I don't know how to read this. Runtime exception. I don't know. Let's make it wider so maybe I can understand this better. So start main. So let's actually see where the error is and try to find it here. It's line 8. Okay, line 8. So please tell me line 8 somewhere. Nowhere to be found. Really? Are you kidding me? With that 1+ gigabytes of tooling, you can tell me where it crashed. Really? And 16 seconds of compilation. Really, that's not even funny, you know. Sorry, I mean Kotlin JPM is good, but Kotlin native is bad. I mean, simply, now I can say don't use Kotlin native. Not good. Didn't pass even the simplest of the tests. Right? And I don't even know how to compile this guy. I mean, let's say debug Kotlin native, and this is from a large company like JetBrains. Okay, let's see, breakpoints typing. Okay, produce binary debug info. Okay, debugger fixes, whatever, debugger. Okay. I don't even understand what this is trying to do. breakpoint. Okay. But it doesn't even tell me. Am I not reading? Oh, use the G option in the command line. Oh, sorry. Didn't read that. Okay, so G option again. I'll time it with G. Okay. $12 what an improvement. Okay. And here we have line 8? We don't. I mean, in Beelang we put the G flag and it worked. In Kotlin we put the G flag and it still doesn't work. I mean, really the worst of them all. So Kotlin native, the worst. It has the prize to the worst programming language of this test. So actually, this easy to debug was useful for discarding one language. Kotlin native can't even fix a simple thing, right? So which one should I choose? Which one should you choose then? Well, it would depend on what you want to do with it. As always, my friends, let me move it a bit here. I'm not that important for this purpose. Let me probably move it a bit more like there. That may allow me to be here. Okay, great. Okay, so that's the table. Now you will interpret it as you wish, right? But first of all, I like IntelliJ. You know, there's people that use Vim, Emacs, whatever they use. I really prefer IntelliJ, right? Because I just want to do control click and navigate and do refactoring and do this and that, and IntelliJ is just the best for that. So far, I am planning to learn Emacs because I think that may be kind of cool, but I'm not sure really. I don't think it will be better than IntelliJ, but I'm willing to try at least. Okay, so if you are like me and you like IntelliJ, you only have a couple of choices, which is D, NIMB, a bit of Julia, not quite. And that's it. That's really it. If you don't use IntelliJ, you can use Odin, Julia, Nim, B, D, and SIG. Maybe you can use Crystal as well, but it's a bit slower, I have to tell you. It takes... This is not a red flag, 311 tooling size. Oh, sorry, it's not red. It's not a red flag. It's fine. Okay, so it's fine. The tooling is not as important. The tooling size is not as important. Sometimes more size is better. Actually, if it provides you better features, but right. So it's not that easy to choose between them. Probably you have to do some in-depth analysis. So let's do analysis of the syntax right here. Beelang syntax, I think is fine. I mean, it's good, really good. You didn't have semicolons at the end of the line. It's easy to write, easy to understand, easy to read. As you can see, it's good. Good syntax. I like it. It's like C, but like Kotlin. Like, okay, it's great. Kotlin, man, it's good syntax, but it just sucks. I mean, right? So we don't just ignore it. Dlang is great. I like it, but it uses semicolons. Lots of times I forget to put them, and I click run and say you missed a semicolon. So, I mean, if you don't bother, that's not a big deal for you, then it's a great language. Remember this one as the smartest optimizing compiler. Yeah, that's I have to tell that. Then we have this bunch search. I can understand everything here. It's great. Now Crystal. Crystal is also very concise, as you can see right here. Very concise. Doesn't need semicolons at the end. Works well. Only this guy right here. Easy way of doing this. Good. Julia. Again, looks good. I mean, of course, this is not very in-depth analysis, but again, acceptable. It's good. Nim. I like Nim. Looks good as well. I mean, all of them look good. Sig. Yeah, it looks good, but it has semicolon at the end of the line. That's the thing. Okay, let me delete that. And that's it. Maybe I'm missing something here. Odin, I guess I'm missing here. It's not here. But let's see if I have it around here. Do I have Odin? Sorry. Can I just quit? Odin. Let me see if I can go here instead. So this is Odin, right? Odin. Run a search at Odin. Okay, as you can see, this is Odin, and it's just fine. I mean, language syntax for this purpose are not bad. Sometimes you have to know that you have to use make slides, otherwise it won't work because it will store it in the in the stack, and that won't be enough. It needs to be stored in the heap and all that. And okay. Why I don't say winner? Because I think this depends on the user. It depends on who you are. You may like some of this and some of the other things. They are fine, but you have to see what you can do with it. Probably you're interested in numerical computing, scientific computing, and Julia is used for that. So maybe you should go there. Even if the IntelliJ support is not the best, I mean, it's not the worst either. So you may go there. So yeah, I mean, this is my table of my chart for the clean and light programming languages. I tried to test them all, right? I really tried. Other guys like OCaml and those were discarded. OCaml and Go, I don't remember which one else, were discarded because, Go, because it's large use of memory, of the energy, and because it doesn't have a plugin for IntelliJ. But okay, but also because its plugin is really it's paid, so we will prefer to have free tools, right? And OCaml was discarded because it used too much memory, like too much. But still, if you want to use them, use them. But these are my recommendations. That is to look at this chart and decide by yourself. If you really want something really small, you have only two choices. These two first, Nim and B, because as you can see, they have relatively fast compilation time and execution time, and it has a really small tooling. It has good IntelliJ support, and both are easy to debug. Our test for easy to debug is not the best test. Of course, it has to be lots more tests to define this, but okay. Then these are the lightest backpack, and that's the reason I didn't include Rust, because that's a heavy backpack. Like Kotlin native even more, probably. But okay. Probably like Kotlin native. But I would say Rust is better than Kotlin native. I mean, if you have to choose between Kotlin native and Rust, I would go for Rust, but I wouldn't choose either of them. I will instead choose one of these guys. Then if you want like still fast mid-sized languages, Tulin, Sig, and D are great, and Odin as well is great. Okay, and they are fast. If for some reason Crystal is useful for you, but like you don't mind being a bit slower, because this is quite slower. A fast language should be below 300 here, probably below 260. Odin, this is great. Then this is the lowest, and it's 231. So it's a big jump, right? So Crystal probably is not the fastest. So here we're like trying to find fast things. And then otherwise, yeah, if you really want to have fast iteration time, B first, D second, probably Julia third, Nim fourth, Odin fifth, Sig seventh, and Crystal eighth. If you want to wait 2 seconds. But 2 seconds in a small program, remember that. What happens if you have a program 100 times the size? Right. Yeah. Which one is good? Sig is good. Yes, it's good. However, not if you like IntelliJ. If you have another ID that's not IntelliJ, would I recommend Sig? Yes. But I will also recommend D. And I will also recommend Odin, Julian, Beam, Nim, and B. As you can see. All of them are great. Or if you like IntelliJ, you only have D if you're willing to write a semicolon at the end of the line. D. However, I think what I would choose probably is between these three right here. For me, these three first languages are the winners for my specific use case. First of all, I didn't want to write a semicolon at the end of the line. Okay. Which is, not that big of a deal, because I could use it. But what is a big deal for me is that it has to have a good IntelliJ support. And actually, I didn't check this. So I shouldn't put good, because I didn't check this. But again, Kotlin native's is bad. Bad. This is the loser. Which one I would choose, as I told you, these three. Because these are the only three that are fast in compilation and execution, have good or medium IntelliJ support, are easy to debug, and don't need a semicolon at the end of every line. Only those three right here can do that. B, Nim, and Julia. Right, because even though I didn't wrote a lot of C or D, even then, forgetting the semicolon at the end of the line was a pain. Right? But okay, it's not the big deal, right? And then, what else should I choose? If not these ones, I would choose D as well. So my ranking is the following. My ranking. We have first a tie. In the first place, we have a tie, as I told you, because I don't know which one of these I may choose between B, Nim, and Julia. Okay, that's the first, the best language. Second one, we have D. Okay. Third, we have. Actually, we won't say tie, but let's do just like that. The third, we have Sig and Odin. Why? Because I don't have IntelliJ support. So Sig and Odin. Fourth, we have Crystal, because it's slower, right? Just and doesn't have IntelliJ support. And actually, probably not. Probably actually Odin is fourth, because it doesn't have IntelliJ support at all. Not even a plugin. Sig kind has, but it's very bad. So you have hopes that it will have better, if you know. So that's fifth, Crystal, and sixth, 100 and 99. Kotlin native. Of course, I'm kidding, right? This is 6. This is the loser. I mean, this is the loser. I have to say, loser. So, yes. There we go. And actually, to the fourth, I would say go for it. If you like any of this, and if you don't mind IntelliJ support. If you do mind IntelliJ support, okay, so we have these tires. So these ones are fast, IntelliJ, no semicolon. So the best, right? Then we have D, which is fast and IntelliJ. Okay, then we have Sig, which is fast and bad IntelliJ. Okay, and then we have Odin, which is Odin fast? Yeah, it's fast. Fast, no IntelliJ, and also it has no semicolons, right? So it's and Crystal, kinda fast. Kotlin native, just bad. Just bad. Okay. So there you go. So this is my ranking. So I will do this, like the better ones. IntelliJ, this one has something. If this one has a smart optimizing compiler. That's something great about D. So it's good, something good. Because this compiler is smart and may find optimization that probably no other compiler right here would find and it will do it in record time, right? But it has semicolons, and that's like a pain in the butt sometimes, right? Yes. Yeah. It's not the big deal. I mean, if you are one, if you don't mind about semicolons, you can use D. I would recommend it very much. It's a great language. But otherwise, you have the first tier right here. Then you have to choose. You have to test them, right? I mean, it will depend if you want something that supports IntelliJ, something that supports semicolons, allows you to not use them. Yeah, so that's my ranking. So I hope you enjoyed the video. I will leave it here. Can I? Well, that's the ranking of programming languages. If you want me to do some tests with these languages, let me know. Write your opinion, like, comment, subscribe, share, whatever. Thanks for watching, and I see you on the next one. Bye.